guys. So today I'm going to speak a little bit about the reactive programming in JavaScript. So what reactive programming is in general and what libraries, modules we have in JavaScript to use to do the reactive programming. So let's start. Yeah. So I am Jovanovic and I work as a senior software engineer in Welltalk. And you can find me on my blog and on Twitter. So what is reactive programming? The first obvious question. So reactive programming is programming with the asynchronized data streams. So this might look strange, so let's start to explain things word by word. So we know what's programming, we know what's asynchronized, so stuff that are not synchronized, so we are not guaranteed that things will go one by one the same way. And the data stream. So the only thing that we don't know here is data stream. So let's see what exactly is a data stream. So the data stream is the endless sequence of digital packets or the digital signals. So basically, this is data stream. Here you see a simple endless stream, and we have those data packets. In our case, it's just some numbers here, so starting from 60 and so on. So this is something that's used in reactive programming to basically display the data. So in JavaScript, reactive programming is basically an abstraction of all async processes into the data streams. That means that we can use some technologies in JavaScript to look at every async thing as a sequence of data. So for example, you can work with some user clicks or user input or WebSockets or some web API in the same way, using the same API and using the same functions. So let's see how. So here we have one stream of clicks. So imagine the user clicks on the mouse 3 times, then he waits, for example, a second, clicks 2 more times, waits for a second, and click only once. So here, let's see how can we transform that data and create some new streams. Right now, we're going to group streams by the time. So we're saying here, like, give me the new buffers for the clicks that happened in the range of 1.5 seconds, in 500 milliseconds. And we got this. So we have the first stream with 3 clicks, second one has 2, and the third buffer has only 1. So this is our stream. In reactive programming, we can do something like this. We can map through each buffer and get the size of that buffer. So the first one has 3 clicks. We get the integer 3. Second one is 2, and the third one, sorry, is 1. We can do also filtering. So here we are saying, like, give me all numbers inside the buffers that are larger or equal to. So our first buffer will stay, second one also, but the third one has the number 1, so it will disappear. And this is our final stream after our simple transformations. So when you saw this example, you were probably asking, why do I need this? So why do I need to learn new paradigm, to learn new stuff like map filter and a bunch of other functions that reactive programming gives us? And there are, let's say, many reasons. So first one is external service calls. So reactive programming gives you one simple way to handle all your API calls, WebSockets, local storage, basically anyone that's async, and you just you get one simple API that's used for everything. You are reading from the WebSockets and transforming the data in the same way that you're reading some post or get API request. Second thing is the web performance. So the data is coming inside your app and going out in the same way every time using the streams. So that's giving you the much better performance than some standard non-stream way. Third thing is it's highly testable. So why? In reactive programming, we just use, so if you are into functional programming, you probably know what's a pure function. That's a function that only has input and output, so no external stuff. So for the same input, it will always give you the same output. We use pure functions a lot in the reactive programming because you're just taking the streams. So the buffers from the stream, you do some transformation with them and you just return the new stream. And for the same input, you will always get the same output. And that's so easy to test, because in your test, you can just give some input and expect to receive the same output every time. Fourth thing is abstraction over all async processes. That's my favorite. So as I said at the start, in JavaScript, you have a bunch of async stuff, async processes. So WebSockets, HTTP requests, user clicks, user typings, for example, drag and drop, everything is async. And you need to wait and handle all those situations. Using some modules for reactive programming paradigm, you can use same knowledge and same functions to handle all those things. Fifth one is predictable code. So your code will be predictable, and user, so some other developer will know exactly what's going on just by reading your code. And the sixth thing is extendable. So with the pure functions, you can just compose them and really easy extend the things and just add a couple more unit tests, and everything will still work properly. So if you ever read about reactive programming, you probably saw this observable thing. So that was my first question when I started to use reactive programming. So what exactly is observable? And that's official terminology for a stream. So observable is something that can be observed. So stream can be observed, and we just subscribe to a stream, and we just wait for some data to come and to work with that. So now that when we know what reactive programming is and what are the pros, let's see what stuff we have for reactive programming in JS. So I have 4 modules here. First one, of course, RJS. That's the most popular and the biggest library. RJS is coming from the ReactiveX community. So the ReactiveX community is also building RX libraries for more than 20 languages like RX Java, RX Ruby, and so on. All those modules have the same API. So if you learn RX Java, you can easily use RxJS or RX Ruby or RX PHP, doesn't matter. And it's the biggest, so sometimes that's advantage, sometimes disadvantage, because it has, I think, more than 200 helpers. Like the ones that you saw, map and filter, there are 200 more, and really in your projects you will maybe use about 20. So sometimes when you don't properly import those methods, you can import whole RxJS and make your bundle really big and have some unused code there. Second one, Mode.js. That's a really small library, and it has best performance, so it's the fastest one. The third one is Bacon.js. So it's a bit slower than Mode.js, and it's really mature, so it's here for a couple of years. And the fourth one, and my favorite, is the Xstream. That's the newest, I think, library. And it's the smallest one, so it only really gives you those 20 or 30 functions that you going to use every time. And also one thing to mention, all those, so these 4 libraries have the same paradigm behind them, so it's really easy to migrate from one to another. because they have mostly the same functions, except the RJS that has even more. So since this is the talk about the JavaScript, I need to mention React and how, of course, how React works with the reactive programming, since that's, I think, the most popular library. So React, some cons for React when it comes to the data flow and the whole React architecture. So first con for React is that data flow. So React wasn't made with the data flow in mind. If you ever worked with React, you know how components are organized, how the component tree looks like. And for making some bigger app and handling some larger data states and data flow, you need to use something like Redux and to write some boilerplate code to make many things work. Also, second thing is side effects. So without any additional libraries, you know how it's hard to work with these side effects in React. So when it comes to reading some WebSockets or sending API calls and then wait and then re-rendering the React without the Redux and some middlewares like Sagas, that's really hard to work with. And the third thing is functional programming. So React is not made with the functional programming in mind. There are a lot of bindings. You probably had many binding issues that you need to fix. There are classes and so on. So those are the React cons when it comes to reactive programming, which is pure data flow and functional programming paradigm. But you know, as always, we can add something to React and fix that. This is the RJS logo. There is a way how to fix this problem in React by adding the RJS and making React reactive. And even better thing is to put the Redux in the middle. So, or basically, the RJS will be integrated into the Redux. So React here depends on the data from the Redux, on the reducers and actions, and so on. And here we can add RJS between the actions and reducers. So when you say like, give me some user from some API in an action, that action can go to the RJS. RJS can send a request, work with the stream, transform the data however you want, and then just return the pure result to the reducer, and reducer will update the state, which will re-render your React app. But I won't talk about that. I am today here to present you something new, something better, in my opinion. That's the cycle.js. Cycle.js is a small library, so it's basically a framework. Something like React. So it's a Vue library, which is based totally on reactive programming paradigm. So with cycle.js, you don't need to use any state handler or anything. So data will just, as the name says, cycle, it will just circle around in a stream format, and you can transform that, re-render your stuff, do the side effects, and so on. So the creator of cycle.js is Anders Stolz. He's one, I think, of the pioneers of the reactive programming paradigm in JavaScript. So I learned a lot from this guy, and if you had time, you can watch his conference talks, YouTube videos, read articles, and you will also learn a lot. So what's the definition of the cycle.js? It's a functional and reactive JavaScript framework for predictable code. So that's what we want in our reactive programming paradigm. We want a functional and reactive JavaScript framework. Cycle.js pros. So those three things were the cons in React. So those three things are now the pros in cycle.js. So in cycle.js, data flow is pure. So you don't need to do anything to explain to cycle.js how you want your data to work and how to circle around your app. It's integrated into the functionality of cycle.js. The data will always go around your app. So, okay, I will say that later when we see some examples. The side effects. So the cycle.js natively handles all side effects. So you have, you can use a bunch of drivers. That's the name of the plugins for the cycle.js. For example, driver for handling DOM changes like inputs, typings, clicks, and so on. There are also drivers for handling WebSockets, for handling API requests, and so on. So you will use the same paradigm, the same code, the same library for handling everything through the streams in the same way. And the third thing, functional programming. Cycle.js is fully functional, so you can easily test things. Components are written as pure functions, where the one component looks like it has the input of the stream, do some stream transformation there, and returns a new stream back to the source. What are the features? So cycle.js is totally functional. You just need to write pure functions, and that's it. It's reactive, so it's natively reactive, and it's based on streams and observables. It's fully testable, so as I said, it's really easy to test the pure functions. And in some apps, in some cycle.js apps that I wrote, I was able to achieve almost 100% of the unit tests. And it's composable, so you just, like in a math or in functional programming, you just write the functions, and then you can compose them. So put one inside another, and that's really easy to isolate. So component can be easily isolated and compose one inside another. It has explicit data flow, so as I said, the data is just circling around. Don't need to write any code to explain how you want the data to work. And it's made for large code bases. So this discussable thing, but I was able to easily work with some larger apps written in cycle.js because there are no actions, reducers, anything like that. So just pure, just files with functions, pure functions inside, and that's it. So this is an example of cycle.js component. So what we have here, the main function you see above is the component, and those are the drivers here. So drivers can be DOM, HTTP, or any other side effect. And the component has, you see, some stream inside. Streams are coming from the sources, from the drivers. Then you transform them, work with them however you want, and then just return them back to the DOM, to the drivers. So example, if you want to read some user input, you will get that data to your app. Then you can read the user input through the stream, create a new stream, for example, make me this label with the text that user has input, and then return that back to the DOM, and that will re-render there. Same thing for the HTTP, same thing for any other side effect. This is how cycle.js looks like. So cycle.js is really small. Without those drivers, it has only this function. And this function is what makes data circle around. So it's called run. It has two arguments. First one is the app, so it's the main, so it is the root component. And the second one is basically an object of the drivers that we want to connect with the root component inside our app. So that's one function. We can compose a bunch of others and then create our views. The drivers that are used for side effects are these. So we have the HTTP, the DOM driver, the WebSocket driver, the local storage driver, HTML5 notification driver, and any others. If you want to use something new, you can easily write your own driver, or there is probably a driver written for your usage. What are the cycle.js official packages? So what comes from the cycle.js creators? First thing, it's the DOM driver. That's the collection, basically, of drivers that work with the DOM. And it has a DOM driver and HTML driver, and HTML driver is based on the snap-DOM virtual library. So, and also, if you don't want to use the HTML driver with the snap-DOM, you can use JSX from React easily. Second thing, it has the history driver for working with the browser history and yeah, just working with the browser history, moving around and making a router and reading from the address bar. Next thing is the HTTP driver. It's a driver for the HTTP requests, get, post, put, so on. It has this cool function isolate. So that's coming as a module, and isolate helps you to isolate your components one inside another. We will see an example later, but basically inside the isolate you put your component that you want to compose inside the root one, and you just send the streams that you want to be input of your child component, and you will get the response of the streams that are coming out of your child component. It has those three versions of the run function. One is the run, that's function for the apps made with the Xstream. Xstream, as you remember, is one of the libraries, and Xstream is made by the creator of the cycle.js. So Xstream is natively supported in the cycle.js. For using RJS or Most.js, you need to use Most run or RJS run, which is also very easy as using the Xstream. In cycle.js, we got a new paradigm, so new Multiview intent pattern. So here you see the main function, the one component, and when you work with the streams, there can be a mess. You don't know what's input, what's output, what's happening inside your function. With model view intent, you can easily just separate parts into the intent. Intent is the part that reads from the sources, from the input, and do some basic transformation there for making the model to really transform the data. And then the view is responsible for sending the result stream back to the driver. And it's easy just to see some example. Let's make a simple counter app. You probably know the counter app. This is the code. So we have in the middle the main function. We will go step by step in the next slides. And at the top, we are just importing the Xstream, we are importing run, and we are importing a couple stuff from the cycle DOM driver, like div, button, paragraph, and make DOM driver that we're going to use in our run function. Then in the middle we write our main function, and at the bottom we just call cycle with the first argument main function and the object of the DOM, where the DOM is connected to just one div, right? Like in the React or Angular or Vue.js apps. So this run function means that we're going to listen for all streams that are coming from the main div, from the div with the ID main, and we are going to send back all the streams as a result back to that div. This is how our simple app looks like when we run it. And this is our main function. So you see there are some empty lines that separate the logic. So the first thing is intent. Here we're making our action stream. By some convention, the variables that represent the stream have this dollar sign at the end. So action dollar sign means that that's a stream. So here from in the action, we just want to merge all the clicks that are coming from those two increment and decrement buttons. So we call the X stream, and we want to merge two streams. First stream is coming from the DOM source. We select the decrement class, and we're picking the event click, and we're just mapping that to be, so every click is becoming -1, and every click in the increment is becoming the +1. So the result of this inside our action stream, we'll just have one stream with the -1 and +1, depending on the button that's clicked. Second thing is the model. So here we want to count the number of clicks. So we take this action stream and we do fold. So fold is something like reduce in functional programming. So we have this callback function where the first argument is accumulator, second one is the current buffer in our stream. And we just sum those two. The second argument is 0, so we say like the first thing in the accumulator will be 0, and then depending on the next buffers from the action stream, it will increase or decrease. So inside the count, we will just have our state change. So it will add +1 or -1 depending on the action or depending on the clicks. And here we are making the DOM. So we are returning the stream back to the DOM to represent our changes. So here we need to so here we need to make basically our DOM. We're taking this count stream that will have some numbers there, and for every number we are sending different div. So we make a div here with two buttons, decrement increment with the classes decrement increment, and we're making the paragraph with a text counter and the data that's inside our count stream. So when we run it, it looks something like this. Sorry, it should be excuse me for this. So this should be a GIF, just to show you that when we click on this, this 0 is changing, but I'm not sure why is this not working. Sorry, guys. Yeah, here it is. So it's simple how it works. So basically, when we click, the streams are coming inside our app and coming outside as a div, as a view change, depending on the input. How does the cycle.js work with the CSS? So as it's based on the snap DOM, so it's taking that functionality from it. The CSS is basically a style object. In this example here, we want to take our VDOM from the previous example and add some color and width and height. So we specify that into the style image, like background color is blue, width is 60 pixels, height is 60 pixels, and then send that as the second argument of our button. Same thing can be done with the div or any other. And as I said at the start, if you don't like this syntax, because I'm not a big fan of this, div, button, paragraph, so on, so writing the functions, you can easily integrate the JSX. Second thing, let's see, so we now know how to handle the DOM changes. And well, let's see, how can we do that with the HTTP requests using the Xstream and the same logic. So this is a whole app. So at the top, we just import one more thing, that's make HTTP driver from the cycle HTTP library. And at the bottom, in the run function, we need to add that make HTTP driver function. So we make the HTTP driver that's listening for all HTTP requests and returning that, putting that inside our main function, but also getting the requests back from the main app. So this is how it looks. And if you go step by step, so first thing here, we make the requests stream using the xstream periodic function. So here we say like make a new buffer every second inside our stream, and map that buffer to the object with the URL and the category properties. So the URL is the URL that we want to send a request to, and the category is important because we need to put a note inside our request, put a name, so we can handle just those requests that we want. Because inside from the HTTP driver, we will get all requests like images or JavaScript CSS files, but we want to look for the ones that we created so we can read the result. Inside this object, we can also put like body, header, or method like get post and so on. The default method is get. So request will make the stream of those objects. So we know, yeah, it's cool. So now let's make a VDOM. So make a virtual DOM stream, where from the sources, we want to select the ones with the category API, and we want to flatten that, because the HTTP source will return us multiple streams. So from those multiple streams, we will just filter the ones we need and flatten that inside the one, because the most important thing in reactive programming is to work just with the one stream. It's really hard to work with multiple. So we make one stream and map through it, so we get just the body from each buffer, and we map through them. So we're taking the result and making a div with the h2 tag inside and the response tags. One thing I skipped here is the start with. So at the start, before that first second where we make the first request, there will be we will have an empty stream. So we want to have at least something just to render the view for the first time. So we make, so we say like start with this buffer. It's an empty response just to render the view with the label response and empty string. And then for every next, cycle.js will do that for us with the request from the API. Okay, so let's see how to work with the components here. Now, when we know how to write pure functions and our pure components, that's really easy. So in this image here, you see one main app with the sources and sinks. Source are the streams that are coming from the drivers, and sinks are the streams that we are returning back to the drivers. We can compose them, so put in one more function inside that will get the same sources or the ones that we want to send to the child component, and the sinks are returned back to the main one, so the main component can work with that too. So we're using isolate function for that, so importing that at the top. Here we are making our constant, so that the sources, that's the object with the streams, so with the reference on the streams. Sources is the object of the stream that we want to send to that specific child component. Then we declare the child component, call the isolate function, where the component so the isolate accepts one argument component, and it's returning one more function. That function accepts the sources. And isolate is returning us the sinks that are coming back from the child component inside the child component variable. So here, when we get some response, we want to make two new streams. In our example, child component VDOM stream and child component value. Example, we are getting from the child component some view, and child component is also returning some value, some calculation. So we are just taking the DOM stream and the value stream back. So our main app can use child component vDOM and child component value to work with them, render them, whatever. So now you saw everything, and it probably looks crazy to you, especially for the guys who already have experience with some non-reactive libraries. So we saw the cycle.js pros. What are the cons right now? So it's excuse me. It's the community. So cycle.js is a new framework. It's, I think, 1 or 2 years old. And the community is not that big, so when you start to write some bigger app, you probably will have some issues that you don't fully understand, and you would like to ask a question on Stack Overflow or try to find an answer that's already posted somewhere on web, and you maybe won't be able. So that's you will be left on your own. But the community is growing. There are a bunch of people who are contributing, and I also saw that some companies are trying to integrate cycle.js inside their systems, so things are getting better and better every day. Second thing is learning new paradigm. It's not just the cycle.js cone, it's basically reactive programming cone. Because reactive programming, when you start to work with reactive programming, you need to change the way you think about the data, about the data handling. You need to learn RxJS or any other library. So that's not that easy. People are spending months and months to change their mind and to try to change their apps. But it's not easy, but it's possible. And third thing is some apps don't need to be reactive. So maybe reactive programming and cycle.js can be the overload for some apps, like some marketing apps and some apps without so much user interactivity there. So reactive programming is basically made for the apps where you have a lot of HTTP requests, a lot of user inputs, and you need to handle that asynchronously. When you don't need to do that, it's maybe better just to use static pages or just to use React without any other modules and additions. So the conclusion, reactive program, so what we learned today about reactive programming is the old paradigm with the new usage now. Reactive programming is, I think, made in the 70s. But it's becoming more popular with the creation of the new frameworks and libraries for the front end, with the larger apps and with more user interactivity. Because 10 or 20 years ago, web pages were just HTML pages with some CSS and some text there. Now with the web pages, you're not creating pages anymore. You're creating really big apps that are sometimes people put them inside the mobile phones. So there are a lot of user inputs, user interactivity, a lot of countings in the back end, communication across different servers, and so on. So right now reactive programming got the new usage, and it's really, doing a really great job there and helping us to create better applications. RxJS, reactive programming, sorry, is not for everyone. So as I said, if you don't have big load on your app, a lot of interactivity, it's maybe not a good idea to start with the reactive programming there. It's perfect for real-time apps that require high performance. Example, you're building some statistics app where you contact 100 servers at the same time to get some data for your charts. You want to refresh your page every 5 seconds, 10 seconds, for example. It's perfect because you will handle all those things in the same way, and data will just come as a stream, stream type inside your app, and you will be able to handle that in the same way, and its performance will be much better than using some other library. It's testable and predictable, and the most important, the best thing, and the thing why people start to use RxJS or any other library is that you abstract your async processes and you just use one library, one API, couple functions to work with different async processes here. So after this talk, I recommend you to go to cycle.js, cycle.js.org website, where there are a bunch of other cycle.js examples. You can even write your code in some interactive editor there and play with it, see how it works. And that's it, yeah. Thank you.